Today the topic of discussion is on moment of inertia, that is engineering mechanics module 4 part 3 ESME 301, that is moment of inertia. So what is moment of inertia? So it is the moment required by a solid body to overcome its resistance to rotation. It is resistance of bending moment of a beam, and it is the second moment of mass, that is mr square, or second moment of area, that is ar square. So its unit is kg meter square or meter to the power 4. So in the figure is an area A, so that area is divided into infinite area. So in such infinite small area, that is dA, at a distance x from the reference axis y and y from the reference axis x. Now we know that its first moment of area about y-axis, that is qy, is nothing but integration x dA, that is area into distance and integration of that. Similarly, first moment of area about its x-axis, that is qx, that is nothing but integration y dA. Now the moment of area about y-axis, that is integration x square dA. So this term is known as second moment of area or moment of inertia about y-axis. So it is called iy, that is integration x square dA, and ix, that is integration y square dA. So equation 1 and 2, this is known as rectangular moment of inertia of the area. Now this is a small area dA at a distance r from the reference axis a dash. Now this term summation r square dA to cover the entire area is called the moment of inertia of an area about a dash axis. Now perpendicular axis theorem, it is also called polar moment of inertia. So the moment of inertia of a plane area about an axis z perpendicular to the plane and passing through the interaction of the x and y axis lying in the plane is equal to the sum of the rectangular moment of inertia about x and y axis. So this is nothing but iz or j equals to ix plus iy. So in this diagram, in this figure 3, it's a small elemental area, that is dA, that is at a distance x from the reference axis y and y from the reference axis x, and r is the distance from the pole. So we can write the polar moment of inertia, that is iz or j, is nothing but integration r square dA. So r square is nothing but x square plus y square. So iz equals to integration x square plus y square dA. So if we split the term, that is integration x square dA plus integration y square dA. So this is nothing but iz equals to iy plus ix. So iz equals to ix plus iy. Now parallel or transfer axis theorem. The moment of area of an object about any axis parallel to the centroidal axis is the sum of moment of inertia about its centroidal axis and the product of area with the square of the distance of CG from the reference axis. Now this is the figure. So in this figure 4, there is an area, that is total area A, a small elemental area, that is dA, and this small elemental area dA is at a distance y from an axis, that is a dash. So that axis is parallel to the centroidal axis, that is b dash. Now that area, small elemental area dA is at a distance y dash from the centroidal axis. Now Ixx from the parallel axis theorem, Ixx equals to Ig plus AD square, where A is the cross-sectional area, D is the perpendicular distance between the centroidal axis and parallel axis. Now, parallel axis theorem consider the moment of inertia, that is Ix of an area A with respect to an axis A dash, denote by y in the distance from an elemental area dA to A dash. So in this figure 5, that is also clear that so Ix is nothing but integration y square dA. Now consider an axis BB dash parallel to the A dash through the centroidal C of the area known as centroidal axis. The equation of the moment of inertia becomes that is Ix equals to integration y square dA. So putting the value of y, so y is nothing but y dash plus d whole square of that into dA. So if you split the term, that is integration y dash square dA plus 2 into y dash dA plus d square into integration dA. Now the first integral is the moment of inertia about the centroid, and that is Ix bar, that is integration y dash square dA. So in the second component of the is the first moment area about the centroid, that is also y dash bar A, that is nothing but so y dash bar AR equals to 0, so the whole term, that is integration y dash dA equals to 0, and the modified equation obtained with the parallel axis theorem is nothing but that is Ix equals to integration y dash square dA plus 2 into integration y dash dA, that term equals to 0, plus d square integration dA. So finally Ix equals to nothing but Ix bar plus d square. Thank you very much.